Have you ever paused to ponder the science behind the ordinary objects that surround us? Take for instance the humble brick, a ubiquitous building block of our world. We often take its reddish-brown hue for granted, but have you ever wondered why bricks are typically red? The answer lies in a captivating interplay of chemistry, geology, and the ancient art of brickmaking. Clay, the fundamental ingredient of bricks, is not a monolithic material but rather a diverse family of minerals with a wide range of compositions. Just as the Earth's palette boasts a spectrum of colors, so too does clay exhibit a natural variety in its hues. The color of clay in its raw, unfired state can offer clues about its mineral composition and the potential colors it might yield after firing. For instance, clays rich in organic matter often appear gray or black, while those with high iron content might display shades of yellow, orange, or red. This natural variation in clay composition is what allows brickmakers to create bricks in a range of colors, even without the addition of artificial pigments. Iron oxide, the compound responsible for the reddish-brown color of rust, plays a pivotal role in giving red bricks their distinctive hue. It's a common component in many clays, and its presence has a dramatic effect on the final color of the fired brick. When iron oxide is subjected to the intense heat of a kiln, it undergoes a chemical reaction known as oxidation. During this process, the iron atoms in the oxide combine with oxygen from the air, forming a new compound called ferric oxide. This compound absorbs certain wavelengths of light and reflects others, giving the brick its characteristic red color. The kiln, a type of oven specifically designed for firing ceramics, plays a crucial role in the brick-making process. It's within the kiln's fiery embrace that the transformation from humble clay to durable brick takes place. The intense heat of the kiln not only hardens the clay, giving the brick its strength, but also influences its final color. As the temperature inside the kiln rises, the water molecules trapped within the clay begin to evaporate. This process, known as dehydration, causes the clay to shrink slightly. As the temperature continues to climb, the organic matter present in the clay burns off, further altering its composition. The most dramatic transformation occurs when the temperature reaches a critical point, typically around 900 degrees Celsius, 1,652 degrees Fahrenheit. At this temperature, the iron oxide present in the clay undergoes a chemical reaction, oxidizing and transforming into ferric oxide, the compound responsible for the brick's red color. While red is the most common color associated with bricks, it's by no means the only one. Bricks can be found in a surprising array of colors, from earthy browns and yellows to cool grays and even blues. This chromatic diversity stems from the presence of different minerals within the clay and the variations in firing techniques. For instance, manganese oxide, another mineral commonly found in clay, can impart shades of brown or gray to the finished brick. While iron oxide reigns supreme in the realm of red bricks, manganese oxide emerges as a key player in crafting the warm browns often seen in brickwork. This mineral, typically found in smaller quantities than its iron counterpart, brings its own unique touch to the brick's final appearance. As the clay undergoes its fiery transformation in the kiln, manganese oxide undergoes its own set of chemical reactions. These reactions, influenced by the kiln's temperature and the presence of other minerals, lead to the formation of various manganese compounds, each contributing to the brick's final hue. Depending on the concentration of manganese oxide and the specific firing conditions, the resulting bricks can range in color from light tans and beiges to rich chocolate browns. To truly grasp the science behind brick colors, we need to delve into the fascinating world of light and how we perceive it. Color, as we experience it, is the result of light interacting with matter. When light, which is composed of different wavelengths, strikes an object, some wavelengths are absorbed by the object's surface, while others are reflected. The wavelengths that are reflected reach our eyes, and our brains interpret these wavelengths as specific colors. For instance, when we see a red brick, it's because the brick's surface has absorbed most wavelengths of light, except for those in the red part of the spectrum, which are reflected back to our eyes. The chemical composition of an object determines which wavelengths of light it absorbs and reflects. The enduring popularity of bricks in construction can be attributed to a combination of factors, including their durability, versatility, and of course, their aesthetic appeal. The color of bricks in particular has played a significant role in their widespread use, shaping architectural styles and influencing the character of built environments. The warm, earthy tones of red bricks, for example, have long been associated with feelings of comfort, stability, and a connection to the natural world. Red brick, with its warm, earthy hues, holds a special place in our collective architectural consciousness. It evokes a sense of permanence, strength, and a connection to the past, making it a popular choice for buildings intended to convey a sense of tradition and enduring value. The color red itself is often associated with strength, passion, and energy. While the aesthetic appeal of brick colors is undeniable, the science of color in architecture extends beyond mere aesthetics. Color can profoundly impact our mood, behavior, and even our perception of space. Architects and designers are increasingly recognizing the importance of color psychology in creating environments that are not only visually appealing, but also conducive to well-being. For instance, warm colors like red, orange, and yellow are known to evoke feelings of warmth, energy, and stimulation. These colors are often used in spaces intended for social interaction, creativity, or activity, such as restaurants, schools, and community centers. The humble brick, often overlooked in our everyday lives, stands as a testament to both the artistic prowess of nature and the ingenuity of humankind. From the geological processes that form clay to the transformative power of fire, the creation of a brick is a fascinating journey that blends natural wonders with human innovation. The vibrant colors of bricks, far from being mere accidents of nature, result from a complex interplay of mineral composition, chemical reactions, and the skillful manipulation of temperature and time. Each brick, with its unique blend of hues and textures, tells a story of its origins, reflecting the geological history of the clay from which it was formed. As we marvel at the architectural wonders built with bricks, from towering cathedrals to cozy cottages, let us remember that these structures are not merely piles of baked clay, but rather intricate mosaics of science, art, and human endeavor.